Hi, everybody. So we're going to be working with the magnetic field simulation and looking at two bar magnets and how the energy between them changes. And I want to just orient you for this simulation. So each of these little dots is a centimeter apart. So I'm going to use that grid to place my magnets. I've got two different magnets here, a stronger magnet and a weaker magnet. I'm only going to be working with the stronger magnet, and then three different blocks that I'm not going to be working with at all. And so if we look up at the top here, we have potential energy, which is measured in a unit called joules. And so we're going to be keeping an eye on what happens with the potential energy, and then also just taking some observations about how the magnets move after I let them go. So let's start off with two bar magnets, and I'm going to work with the two strong ones. And you're going to notice immediately that the potential energy changes. We're not going to pay attention to this quite yet. I want to first rotate them into the position. So I've got one bar magnet with, we're going to say the blue side is south and the red side is north, with the north side facing to the right, and another bar magnet. We're going to put them both with the north sides facing to the right. And this is a little annoying sometimes to try to rotate them. There we go. And they are three dots apart, so 3 centimeters apart. And we're going to notice that the potential energy right now is at 6,815.7 joules. So I'm going to go to my data table, and you've noticed that I've already written that down, that the starting energy before I let them go is 6,815.7 joules. So I'm going to go back to my sim, and I am going to now let go and run the sim and see what happens. So let's hit the run button. So now my potential energy is 4,497.9 joules. And I want you to write that in your data table and also write down what happened to the magnets. So did they move apart? Did they move together? And I'll run that one more time. So I'm going to hit the reset button. So I've got, again, our starting energy is 6,815 joules, 0.7 and 7/10 joules. And when I run it, after I run it, the potential energy is 4,497.9 joules. And they've moved together. Okay? So that was our first round. Let's try something a little different. Now I'm going to move these so that they are 9 centimeters apart. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me drag this a little closer. Oops. Drag this a little closer and count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And now our potential energy is 7,113. Oh, so it's different than our starting potential energy before. That's interesting. I wonder what our ending potential energy is going to be. Let's find out. So take a moment, write this down. So 7,113.4. Write that in your data table under the 9 centimeters. And I'm going to hit run. Oh, wow. 4,497.9 joules. I think that's the same as it was before. Interesting. So even though we started with more potential energy, we ended when they're touching and they can no longer move with the same amount. Let's enter that in our data table. And I'm going to show that one more time. So again, they're 9 centimeters apart, and the starting potential energy is 7,113.4 joules, 7,113 and 4/10 joules. And after I run the simulation, our ending energy is 4,497 and 9/10 joules. Pretty cool. Let's try something a little different. So for my third experiment, I'm now going to put these back so that they're 3 centimeters apart, so 3 little dots apart, and I'm going to flip, I'm going to flip the magnet. But I'm going to flip it so it matches what you see on your data table. So we're going to have both south sides facing each other. Okay, and our starting potential energy now is 5,020 and 9/10 joules. Or, 7,520 and 9/10 joules. Again, 7,520 and 9/10 joules. And let's see what happens when we run the simulation now. Where are they going to go? That's interesting. And now we have 7,169 and 1/10 joules. So it looks like we now have less potential energy, but I'm not sure. Let's run that again just to make sure. So when they're closer to each other, we start off with 7,520.9 joules. And then when I run the field, or when I run the simulation, and they move apart, the potential energy drops. I wonder why that is. Maybe they're just as far apart as they can get and they're not moving anymore, but I'm not sure about that. I think we need to do one more test. And I'm wondering what happens when I move them so that they're 9 centimeters apart. So I'm just going to pull them, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 centimeters apart. And so now we have 7,223.3 joules. So 7,223.3 joules. Let's get that in your data table. And you can always hit pause. Let's run again. And they're moving more slowly. And it looks like our ending potential energy again is the same. Interesting. Let's run that again. So when I run it, let's see what happens. Again, the potential energy is dropping. That's interesting. Now for this last shot, let's do one more thing. I'm going to turn on the field lines so we can see the magnetic field. They're yellow. And if we notice, and they're spread apart, we notice that the fields are sort of looking like they're pushing against each other. They're not touching. And if I hit run, let's see. So again, it's moving a little more slowly. Okay. So I hope that this simulation was helpful for you. I hope you got all your data and your observations down. And now let's think about what we just observed and what it means.